Hello and welcome to Insight Ophthalmology. This is Dr. Amrit welcoming you to part 2 of the Topography and Tomography series. In part 2, we shall be studying about the various topographic maps or the tomography maps. The tomography maps particularly are of 4 types, and this is in reference to the pentacam. Because in pentacam specifically we have these 4 maps and together they are called the quad maps. Quad stands for 4 and maps are maps. So the 4 important maps that we should all know are: number 1, the axial map or the sagittal map, the elevation map in which we have the anterior elevation map, the posterior elevation map, and then we have the pachymetry map, also called the thickness map. So this is how 4 maps we get in pentacam, which is a Scheimpflug based corneal tomography system. So we have 4 maps, that is the anterior surface axial map, which is also called the curvature map. Then we have 2 elevation maps, that is one from the anterior surface anterior elevation and one from the posterior surface, that is the posterior elevation map. And finally we have the pachymetry map or the pachymetry display. Now let us have a look at them one at a time. The first map that we have is the axial map, also called the anterior sagittal map. Now in the axial map is going to depict nothing but the curvature of the anterior corneal surface, and this curvature will be depicted in dioptric values, that is in diopter. So at every point the system is going to calculate the radius of curvature and convert it into diopters and represent it according to a color scale. So this is the anterior curvature map and this is the scale. So just have a look at the scale. The yellow, oranges and red color are basically the warm colors, and the green, blues and the violets are the cool colors. Now the warm colors basically signify danger. So what I mean to say is that whenever the warm colors are present, that is the red colors, in particularly the red area that is over here, you can see the radius of curvature is quite more in this area, about 54, 53, 51. So this area of danger, which is represented by warm colors, actually represent steepening of cornea. So what is meant by steepening of cornea? So if you have a normal cornea like this and if the cornea is more elevated from its normal point, that is called steepening of the cornea, and if the cornea is flatter, it is called a flatter cornea. So flatter cornea, which means it is having less curvature, will be represented by the cooler colors, because the flatter cornea is going to have less power in diopter, so it will be in cooler colors. As you can see over here, this is all blue area, and the steeper cornea will be represented in the warm colors. Now the axial maps are really important, not just the color coding. We should also know certain kind of shapes which are present on the axial map. So based on the shapes, we have symmetrical shapes, certain asymmetrical shapes, the skew shapes and certain special shapes. Let us talk first about the symmetrical shape that we see on the anterior axial map or the axial sagittal map. Now the symmetrical shapes could be, we could have central steepening area, that means the steep area which is present only in the center. So we will have such roundish reddish area in the center. This is called the round symmetrical shape. Or sometimes the central area would be steep in a form of an oval. Or sometimes you are going to get this bow tie, right? So bow tie is what we wear on our shirts. So similar to that, we are going to get this bow tie like this, which indicates that only one meridian is actually steep. And this is also seen in the with the rule astigmatism, in which the vertical meridian is more steeper. However, this is all normal when the Kmax value, that is the total keratometry value, is actually less than 47. So whenever your Kmax will become 47 diopters with these shapes, then it indicates that there is a moderate risk of ectasia in these people. Similarly, when the Kmax is above 50K, then definitely there is a risk of ectasia, and it is a very high risk of ectasia. So what I mean to say is that symmetrical shapes are good shapes. They are good shape, they are normal shape, as long as the Kmax reading on keratography is or topography is less than 47. Whenever the Kmax reading is above 47, then these symmetrical shapes can also possess a danger of ectasia. Specifically, if it is 47, it is moderate risk, and when it goes above 50 diopters, then definitely it is abnormal and you have to consider about ectasias like keratoconus. The next type of shapes that we see in the axial maps are the asymmetrical shapes. So in asymmetrical shapes, what I mean to say is that there will be steepening in a part of the cornea, but it is not symmetrical in the upper and the lower quadrant of the cornea. So the first type of shape is superior steep. So in superior steep, only the upper quadrant, you can see such an area of steepening present only in the upper quadrant like this. Okay, this is called superior steepening. Or you can get a bow tie, but this bow tie will not be symmetrical. So you can see this is a bow tie shape. So there are two circles which I have drawn, but the upper one is bigger than the lower one. That means there is an asymmetrical bow tie, and because the upper one is bigger area, that means the upper one is more steeper. Now it could be asymmetrical bow tie with superior steepening. So just look at this. Here also there are reddish area, reddish zones, but the inferior quadrant is having greater area, and therefore that is the inferior steep quadrant. Similarly, you can have a cone, or you can have this reddish steepening area on the axial map just on the inferior quadrant, which is called inferior steep, right? Now, asymmetrical shapes can also be normal when the inferior and superior dioptric readings or the curvature readings are less than 1.5. So what I have written over here, asymmetrical shapes with inferior superior difference of more than 1.5 means that there is danger. Okay, means that there is a risk of ectasia. So this superior steep, if you take a point over here and if you take a point over here and see their dioptric value, okay, say xd and this is yd, x minus yd should be less than 1.5 diopters. Similarly, in this asymmetrical bow tie with superior steepening, you take a point here x, take a point here y, and subtract those two dioptric value, it should be less than 1.5 diopters to be normal. Similarly, here the inferior superior difference should be less than 1.5 diopters to be normal. Similarly, here also it should be less than 1.5 diopters to be normal. But so what you have to remember in asymmetrical shape is whenever the superior inferior difference is more than 1.5, then it is a danger of ectasia. Now let us talk about the skew shapes. So what is meant by skew shape? Skew shape means that normally we have a symmetrical bow tie like this. Okay, so the axis of this symmetrical bow tie is actually say 90 degree. This bow tie, this part of the bow tie is also present on 90, and this part of the bow tie is also present on the same axis. However, sometimes what can happen is that the bow tie can get twisted towards another axis, and this is called a skewed axis. Okay, this is called a skew in the axis or a tilt in the axis. So this first picture which is showing one diagrammatic representation of a topograph, we have a symmetrical bow tie because both the parts are equal, and however this upper part of the bow tie is actually tilted towards the right side, and this is called skewed radial axis, which is represented as SRAX. Okay, skewed radial axis towards the right side. And now over here there is a bow tie, but the bow tie is of different shapes. The inferior one is more, so we can say asymmetrical bow tie with inferior steepening, and along with that there is a skewed radial axis. Okay, again it is radiated, it is tilted towards the right side. Just like there was a twist in the symmetrical and asymmetrical, similarly in skewed also there is a twist, and the twist is that the skewed radial axis, this tilt, should always be less than 22 degrees. Wherever the skewed radial axis is more than 22 degrees or equal to 22 degrees, then you have to consider it as a risk of ectasia. Okay, I hope that is clear. Now, After those symmetrical shapes, asymmetrical shapes and the skew shapes, we have certain special shapes, and these special shapes are almost always they are abnormal. Okay, so we can have a butterfly shape like this, okay, which is looking like a butterfly, or it could look like the crab claws. Okay, so it is called the crab claw appearance on topography, or it could be irregular astigmatism, which will show irregular steepening like this. And almost always all the special shapes are actually risky, because this butterfly shape and claw shape you see in actually pellucid marginal degeneration, which is a type of ectasia. Now just have a look over here. So this picture, you can see the color coding, you can see this purplish reddish areas are the steeper areas, and you can see here actually this is a classic crab claw appearance on the topography on the axial map, on the axial curvature map. Similarly here you can see this is the claw and these claws are closing together. So these both are seen in pellucid marginal degeneration, which is a type of corneal ectasia. Now let us summarize the high risk shapes and the moderate risk shapes which are present on the axial curvature map or the anterior curvature map. So all the special shapes will tell you that there is a high risk. All the skewed radial shapes, okay, with the skewed radial axis of more than 22 degrees is high risk. Central shapes with K-max or the symmetrical shapes with K-max of more than 50 degrees is definitely a high risk of ectasia. Moderate risk, that is asymmetrical shapes in which the inferior superior difference, that is IS difference, is more than 1.5 diopters, definitely it is a moderate risk. Central symmetrical shape with Kmax of 47 diopters to 50 diopters is a moderate risk. Now let us talk about the elevation map. So in elevation map, we had two types of maps, the anterior elevation map and the posterior elevation map, which can also be called the anterior float and the posterior float, and they are present on the pentacam. Now they display the shape of the cornea by actually comparing it to a computer generated best fit sphere. Okay, so in the anterior float is nothing but comparison of the anterior curvature with a reference, and the posterior float is nothing but it is comparing the shape of the posterior cornea with a reference. Now the reference that is present here is two types, the best fit sphere and the best fit toric ellipsoid. So let me tell you about them one at a time, but first let us understand what is meant by the concept of triangulation, which is specifically present in elevation based tomography, that is the pentacam or the shine flux and the slit scanning like the orb scan. So in the navigation also what happens is that whenever the concept of triangulation is that, suppose this is the ship, okay, if we do not know the coordinates of the ship in space, so where exactly the ship is present, if we know the points A and B, and if we know the projection of these lines, that means say A is projecting at the ship and B is also looking at the ship, right? So if we know the distance of A to B, and if we know the angles the A and B are subtending to this particular ship, we can actually find out the coordination points, that is X, Y, in the space of the ship. Okay, so similarly that is what is done in the sky flux technology also. When we do not know anything about the cornea, what we know is a projector is there and there is another camera which is actually capturing the images. We know where the camera and the projector is present and where the projector principal point is there, where camera's principal point is there, and both of them are coming at a focus point on the cornea. Now because we know these points, if we draw a triangle like this, we also know the angles they are projecting, say alpha and beta, on the cornea. So if we know these angles and if we have these two fixed points, we can calculate the coordinate spaces, that is the coordinate points of this point on the cornea. Similarly, all the points of the cornea will be screened based on this concept of triangulation. So it's not very important, but just to for the sake of completion of the video, I have included it. Now, as I told you that in the elevation based system or in the elevation maps, unlike the anterior curvature map in which we have the raw data, so we had this cornea in which here it was 45 diopters, say here it was 43 diopters, 30 diopters, like that. Okay, but in the elevation map we have a reference point. Based on this raw data, we are going to have a normal point of the averages of all the normal corneas, and then we are going to compare the patient cornea with that reference. So we have, just like we have mountains on the earth, we have valleys on the earth, right? And we are comparing the height of the mountains from a particular sea level, okay, which is taken as 0. So from there we are actually calculating the height, okay, of the mountains and the depth of the oceans from a particular sea level as a reference. Similarly, in topography also we can have a reference, and based on that we can calculate two maps, the anterior elevation and the posterior elevation. Now what are these two references? The first reference and the most commonly used reference, which is easily to calculate and easy to apply, is the best fit sphere. This reference, as the name suggests, is actually in the form of a spear, and this spear we will apply on the 8 mm central zone of the cornea and then compare our cornea with this reference. Okay, now another kind of reference is the best fit toric ellipsoid, which is slightly conical in shape. Okay, and because of its conical shape, it is very it can actually miss sometimes the cones which are present in keratoconus, and therefore it is said that the best fit spear is more advanced and it's more better to diagnose the conical shapes of or the keratoconus. Now, so as I told you that the elevation data is not exactly seen in raw form in the elevation maps. These elevation maps will actually tell you the actual corneal elevation data and compare it and how much it is deviating from the known shape. So let us see over here. So suppose this point over here, this dome is the reference surface or the best fit sphere, and this green shape over here is our cornea. So all the points which are present above this reference plane will be given a plus sign, okay, and how much are they elevated from that point will be given it as a number, okay. And similarly, all the points which are below this reference plane will be given a negative symbol, and how much they are depressed from that point, that will be given in the number, okay. So suppose this is the normal cornea. So in a normal cornea, the normal fit with best fit sphere will be seen, and the cornea and the best fit sphere will be together, and the difference will be almost like 0. Okay, so there will be 0. That means both are coinciding. However, in a keratoconus, just look over here. This is the cornea and this is the best fit sphere, and you can see a certain part of the cornea is actually projecting beyond this reference because this is the cone. Okay, in keratoconus, what happens? The cornea becomes conical. So this cone part is actually projecting above this reference sphere, and it will be represented as a plus value and in a red image on the elevation map. Now, how do we get this best fit sphere? The best fit sphere is actually calculated from the raw data that we are getting from the anterior curvature map. Now in keratoconus, what happens is that the central part or wherever the cone is present, that will have very high values, right? So because the best fit sphere calculation is taking into consideration this entire area of the cornea, the best fit sphere will also be elevated because of these central elevation points, right? So what happens is that sometimes when you put this best fit sphere, which is elevated because of this keratoconus, you might actually miss very small keratoconus because the difference between the keratoconic cornea and the reference point, that is the best fit sphere, which was calculated from the keratoconic cornea, is very, very less. So this can pose a problem in detection of certain normal corneas. Okay. However, what if we calculate a best fit sphere but we do not include this conical part? Okay, so if we do not include this conical part, only the normal cornea is actually included for calculation of the best sphere. So we will get a new reference shape like this, and in this reference shape you can see now the distance between the cone and the reference plane is more, and now it is easier for us to actually understand and to diagnose even the early keratoconus. So such a new best fit sphere that is calculated by excluding the conical part of the cornea is called the enhanced best fit sphere. Okay, so this is called the enhanced best fit sphere. So in enhanced best fit sphere, the central conical, or wherever the conical part is present, around that elevated, wherever the maximum elevation or the maximum curvature is present, around that 3.5 to 4 mm circle of cornea is actually excluded from the calculation of the best fit sphere, and we will get the enhanced best fit sphere, which is better in diagnosing of the early keratoconus. Okay, yeah. So you can see over here, this is the elevation of the front and this is the conical part you can see. Now this conical part will be excluded from the calculation of best fit sphere, and then it will be calculated and it will give us again another new sphere, best fit sphere, and a new elevation map which will have a different color coding. And in that color coding, if you see a reddish area like this, it indicates that there is a cone which is present, or there is a steepening which is present. Now this is what brings us to the Bellin's Ambrosio enhanced ectasia display, which is also called the bad display, or which is a bad map, which is very important feature of the pentacam, in which the best fit sphere is converted to the new reference shape, which is the enhanced fit sphere. So what happens, initially we had these elevation maps which were calculated for the anterior surface and the posterior surface using the best fit sphere. Then what we did was we eliminated the ectatic areas and we calculated a new one. So this was the new maps that we got through the enhanced best fit sphere, and then we are going to subtract this first one maps from the second map, and we are going to get a difference map like this on the bad display. And these difference maps can again be color coded, and you can see if the difference is more than 7 to 9 microns, it is given in red color. If it is 6 to 7, it is yellow, and if it is less than 5, it is green. So more is the difference, more is the color, more is the danger color, that is the red colors, and it indicates that there is ectasia. Okay, so the first map that we calculated using the best fit sphere is called the standard elevation map. The map that we calculated by excluding the conical part or the steepened parts and the 4 millimeter circle around it is called the exclusion elevation map. And then we are going to subtract and get the final difference map and look at its color coding. Now these are certain normal patterns of the elevation map. So you can see this is a central island of steepening, but it is not still in yellow color. It's not in the red color, it is in the yellow color, and this is a normal central island. And similarly over here also is an astigmatic elevation map. Now there are certain important things that on the elevation map also we have to consider the thinnest location and calculate the elevation of the thinnest location on the elevation. What I mean to say is say in the pachymetry map, or that is the thickness map, say X is the thinnest location, you find the corresponding elevation point of X on the elevation map in the anterior surface, and that point should always be less than 8 or equal to 8 in a myopic patient. In a hyperopic patient, it should be less than or equal to 7. Now, if you compare the same thing on the posterior elevation map, in the myopic patient, it should be less than 18, and in the hyperopic patient, it should be less than 28. Any reading which is more than this can be suspicious of keratoconus or ectasia. So that was all about the elevation maps, and now we shall be studying about the last type of maps. Those are the pachymetry maps. The pachymetry is nothing but it is the thickness of the cornea. So the thickness of the cornea can also be represented in a form of a map, in the form of a color coding, and that is called the pachymetry map. So you can see here it is all bluish in color, which indicates that it is normal. So bluish, greenish, cool colors are good corneal curvature or good corneal thickness, and the red ones indicate that there is thinning. So usually because corneal ectasias like keratoconus, they not just have steepening, they also have thinning, and therefore the pachymetry maps are also equally important. In the pachymetry map, you should see where exactly is the thinnest point located, what is the reading of the thinnest point, and then you have to take 2 points symmetrical, that is one X and Y at the same point almost, and then carry out the difference between their thickness. So this difference between the inferior superior should always be less than 30 microns. Okay, whenever the difference between superior and inferior is more than 30 microns, it indicates that there is a significant thinning and it can be risky and it can suggest ectasia. Similarly, you have to find out the thinnest point, and suppose this is say in this picture the thinnest point is about 485, and then you have to calculate the vertical displacement of the thinnest point from the center. So what it is believed is that normally the thinnest point is present in the center. The cornea is thinnest at the center and then it becomes thickest at the periphery. So if there is any inferior displacement of this thinnest location, which is represented by the y coordinate, and that thinnest location displacement is more than 0.5, it indicates that there is a risk. Okay, so I'm so sorry, this should be less. So what I mean to say is the displacement should be less than 0.50 and the superior inferior asymmetry should be less than 30 microns. I have given it a minus symbol because I am referring to the inferior displacement of the thinnest location on the cornea. Now this is a picture. We can see the entire cornea itself is looking red because there is an almost global thinning of the cornea, and this is seen in keratoglobus. Similarly, in pellucid marginal degeneration, we all know that there will be inferior thinning, and the type of map on the thickness map is the bell-shaped map. To summarize the pachymetry maps, you look for the thinnest location, thinnest point on the map, then you look for the shape of the maps, you look for the inferior and superior symmetry, which should be less, the difference should be less than about 30 microns. Then you look for the shape of the maps, whether it is a bell-shaped or a global map, which is definitely a dangerous type of maps. Then we should also see the displacement of the thinnest location, which should be less than 0.50. If it is more than that, that means definitely there is a ectasia. So that was all about the maps. In my part 3 on topography, I will tell you about the steps in which you can go about reading the corneal topography or tomography very easily. In my part 3 only, I will also be covering about the other aspect of the bad display, that is the corneal thickness profile and the percentage thickness increase of the cornea. So that was all for today. Thank you and have a nice day.